In this video, we're going to be going over simplifying fractions. So simplifying fractions is the basis of fractions, as most solutions will always have the final answer be in simplified form. Let me give you a basics of simplified fractions. So we know that fractions represent a graphical breakdown of parts and wholes. So say I have a block that is divided into pieces. Now say I shade one part of that block. I would write the fraction of shaded part, or the shaded part of the block, to be 1 over 2, as one out of the two parts of the block is shaded. Now let's say I keep the same block, but I now divide it into 4 pieces. As you can see, my denominator has changed, but so has my numerator. So now that I have 4 pieces, it seems, or it's shown, that 2 pieces are shaded. So in other words, 1/2 is equal to 2/4. Now let's say I break down the block again into another equal piece, and here it's now a total of 8 pieces. And we see that 4 pieces are shaded. I could continue this, but as you see, 1/2 is my most simplified form. This is the basis of simplifying fractions. Now, when it comes to simplifying fractions, it's very important that you understand prime factorization. You should also recognize common factors. Now, say for example, I have a value 8. Now, I want to prime factorize my number 8. So what that means is, I first start with looking at or identifying two numbers. When I multiply them together, I get 8. You can come up with any two factors as long as they're correct. So I'm going to start with 4 and 2. Now, I know that 2 cannot be broken down as it is prime, so I'm going to go ahead and circle it. But 4 can get broken down into 2 and 2. 2's again are prime, so we go ahead and circle it, meaning that 8 can be prime factorized as 2 times 2 times 2, or in exponential form, 2 cubed. Now, let's say that I have an example of a fraction that I wish to simplify. Now, when it comes to simplifying fractions, you can always do prime factorization, where you break down the numerator and denominator into its prime factors and cancel out any common factors that exist in the numerator and the denominator. Here we have 2 over 6. If I wish to prime factorize 2, I can't break it down any further because it's prime. So I can just write it as 2. The 1 is not important, so you don't have to write it out. But I can break down 6 to be 2 times 3. 2 and 3 are both prime, so in that case, 6 can be broken down to be 2 times 3. Notice that I have a 2 in the numerator and the denominator, so I can cancel it out. Now recall that I didn't write the 1, but that doesn't mean it's not still there. In that case, I am left with just 1 in my numerator and 3 in my denominator. This is its simplified form, as 1 and 3 cannot be broken down any further. They are prime, and they do not have factors in common. Let's do another example. Let's say we have 15 and 6. Let's go ahead and break 15 down into its prime form. So picking any two numbers, and when I multiply them together I get 15, I have 3 and 5. 3 cannot be broken down any further, so it is prime. 5 can also not be broken down, so it's just 5. So 15 can be written as 3 times 5. In the previous example, I said that 6 can be broken down to be 2 times 3. So I can write 2 and 3. Notice I have a 2 in the numerator, a 3 in the numerator, and a 3 in the denominator. So this just becomes 5 over 2. Let's do one with multiple digits. So say I have 100 divided by 125. Let's go ahead and prime factorize 100. Picking any two numbers, I can break down 100 to be 50 and 2. Notice that 2 is prime, so you don't have to break it down further. However, 50 can be broken down to be 25 times 2. Circle my 2 because it's prime. I can break down 25 to be 5 times 5. So my numerator 100 is 2 times 2 times 5 times 5. Keep in mind, it doesn't matter which two factors you start from, you'll always get the same prime factorization. Doing the same thing for 125, I can break down 125 with 5 times 25. 5 is prime, so we circle that down, but 25 can be broken down to be 5 and 5. So my denominator can be written as 5 times 5 times 5. Again, I have 5s here and here, which I can cancel out. But I also have another 5 in common, and I'm left with just 2 times 2 in the denominator and 5 in my numerator and 5 in my denominator. 2 times 2 gives me 4, and 5 is just left alone. Let's continue with one more example. So here we have 16 and 18. Breaking down my 16, any two values, I'll have 4 and 4. Breaking down my 4, this gives me 2 and 2. Similar here is 2 and 2. So 16 can be written as 2 times 2 times 2 times 2. My 18, when broken down, I get 6 and 3. 3 is prime, but 6 can be broken down to be 2 and 3. So I can just write it as 2 times 3 times 3. I only have one value in common in my numerator and the denominator, which is 2. I am now left with 2 times 2 times 2 divided by 3 times 3. I know that 2 times 2 times 2 is 8, and 3 times 3 is 9. So my simplified form is 8 over 9. This is all for this video, and we will continue on in the next one.